they have been studied in our community for over 3 decades, and also they have been applied. So have you considered reusing that? Because why to reinvent the wheel?
There are definitely, I know there definitely are some researchers that are looking at things from a more, from an existing autonomous agent perspective, though that definitely is probably an area that has been, a lot of it has been underexplored.
Mm. So I published a bunch of papers about smart contracts last year, but I come from a very different direction. In I look at collaboration programs and collaboration models, and then I break that down into ontologies, which could be guiding for designing all sorts of different versions of smart contracts. But it goes much. So you said there's a distinction between a smart contract and a legal contract.
Yes.
And it would be interesting if that claim really holds, because if you, let's say, build an application layer on top of the Ethereum type smart contract, then you could actually blur this sharp distinction, couldn't you?
Maybe. So there definitely are situations where I think the two can kind of interact with each other.
Mm-hmm.
So one example that I brought up is this sort of legalese approach of, having a legal contract component and a smart contract. Another approach that people are looking at is having having blockchain-based organizations that are at the same time tied to some kind of legal layer. So the idea basically is that if the smart contract emits a certain kind of receipt, then that counts as a legally enforceable signature. And there are companies that are kind of looking at that approach.
Mm-hmm.
So there definitely are people that are sort of interested in combining them in different ways.
Mm-hmm. Mm-hmm.
Yes.
Could you elaborate a bit more about insurance applications? What are there besides peer insurance?
Yeah. So I mean, the concept of insurance is pretty simple. So basically, or at least interestingly enough, the way that insurance originally worked is this peer-to-peer model. So you had a bunch of people, ship owners come together, sign a contract that says if one of our ships sinks, then we'll all agree to cover part of it. So it's something that could be applied very generically in areas where people have risks that they want to mitigate. So practically speaking, the areas that I've seen people looking at peer-to-peer insurance for so far are, one of the use cases is things that just can be very easily verified. So things like flight cancellations. There's actually a project that does sort of flight cancellation insurance on top of Ethereum right now. There's and people are looking at other kinds of insurance. So whether it's unemployment insurance or crop insurance. I guess hedging is a kind of insurance and so forth. The challenges in some cases are that for many kinds of insurance, the problem of evaluating claims becomes a very hard one. And so that's, as I mentioned, an area where smart contracts by themselves aren't sort of fully capable of solving things. You have to figure out exactly what mechanism does. But other areas are kind of easier to check automatically.
Question? So, what happened to data science? I was wondering if you hear this term data science, combine those two, those three things that belong to think of, for example, steps. Directors have this chain graph and block synchronization and those kind of things, but how can you comment on this kind of data science and
Yeah, I mean, I think that there is going to be very many data science opportunities if blockchains become more popular, basically because, they fundamentally are extremely public databases, and you have access to much larger quantities of information that potentially, weren't available before, and particularly were only available before within the context of proprietary silos that didn't share it with anyone else. So, with open source data sets, you have opportunities to, do different kinds of statistics, try to figure out sort of what kinds of patterns of interaction between people exist. I think it's still a bit early because the problem with Ethereum particularly is that it's still early stage, and so not enough people are using it that we kind of see, large scale patterns of activity that are sort of worth doing data science on. But hopefully within a year that'll change. On Bitcoin, which has existed for over 6 years now, there have been people who have been trying to do analysis. They've been trying to, let's say, identify what kinds of identify what the number of actual users is. They've managed to de-anonymize large accounts in some cases. They've managed to try to figure out what people's preferences are regarding holding coins versus paying them quickly, sort of which entities interact with each other most often and so forth. So it definitely is an area that's already being looked at. Yes.
You said that the state is the code, but the code basically waits on the events to come, right?
Yes.
So I wonder how events get into the code state.
Right. Okay. So so there's several different kinds of events, right? So in general, the way that Ethereum works is that it is a state machine. So contracts only modify their state when a transaction or a message from another contract hits them. So basically, in order for any kind of events to happen, it has to be triggered by something. Now that said, you might want to have a smart contract which is triggered by some events, which is, let's say, either time passing. So let's say you want to have a contract which automatically sends money to some people on, let's say, January 1st, or you might want to have a contract that sends something if people do if something outside of the blockchain happens. So in both of those cases, you basically need to kind of create layers on top of the blockchain that sort of automatically sort of ping contracts, and by sending transactions to them when those particular things happen. So for example, there's a service already, a decentralized service already running on top of Ethereum. It's called Ethereum Alarm Clock. And the way it works is that contracts can set up bounties, and they basically say, whoever calls me for the first time after, let's say, Unix timestamp 1.6 billion will receive a reward of 0.01 Ether. And the theory is that, whoever ends up calling that contract first gets the reward, and because of that, basically, they have the incentive to try to ping that contract as quickly as possible after Unix time 1.6 billion, and so you kind of roughly have a timed event. For things that are completely sort of outside, so, winning presidential elections, the prices of real-world tokens, and so forth, that does require data feeds, and it does require, potentially some notion of trust, though as I've described, there are kind of ways to mitigate it.
So, you said blockchain, is it like a smart contract all contained in there, or does it have some integration with real world in terms of
So, right, so theoretically, smart contracts can run on different kinds of platforms. If we're talking about blockchain-based smart contracts in particular, then the smart contracts do run inside of the blockchain, and the blockchain isn't really aware of anything about the real world, except for a few very limited things like time. So because of that, if you want to have some kind of link to the real world, there are two types of links. So the first type of link is when an event, you want the blockchain to have parts of the real world as an input. So let's say a smart contract that depends on, let's say, the price of gold or the exchange rate between Swiss francs and US dollars. In those cases, you need to have some kind of data feed. So you need to have some set of entities that creates signed messages saying, this is the status of this particular piece of data at this particular piece of time. And the theory is that if you can come up with some set of entities that are trusted, then you can kind of rely on them to feed the data in. The second piece is, how can you create smart contracts where the smart contracts can have real world outputs? So generally, the way that you want to do this is you want to create systems in the real world which listen to these logs that are emitted by a smart contract. So there's smart contracts, they have an option to sort of emit logs, so kind of create messages that don't go into the state, but which kind of are visible and from by any node that's running the blockchain. So as contract creates one of these logs, then a node, whatever object in the real world listens for these logs, and when it finds one, it acts in some particular way. So this is how let's say these select devices work.
So for example, this digital will,
Yes.
you would have to either complete
Right, so for
verification
digital, so right now, these digital wills can only work in the context of assets that sit on top of a blockchain. Now, if you want them to interact with, let's say, money in your bank account, or let's say your house or something similar, then chances are you would probably need to do some kind of legal work in order to, I mean, you could theoretically, you know, sign a legal contract that says, please honor the results of this particular smart contract on the blockchain, and you might decide to, you know, talk to some lawyers, figure out some way to make sure that's actually going to happen and it's sort of legally robust. And there are kind of companies that are trying to work those things out.
More questions?
Yes.
Another question. So there is a company called Chain focused on building blockchain networks.
Yes.
What are the core differences compared to Ethereum?
So Chain, as I understand it, is developing a private blockchain solution. They're working with NASDAQ right now. So like a lot of these private blockchain solutions, they tend to be more specialized. So they tend to be designed around particular objectives. So in this particular case, whether it's like stock trading or something similar. You know, private blockchains and public blockchains have the obvious difference that private blockchains tends to be more efficient because they have fewer nodes, but they're also kind of less open, and because, you know, you're only allowing trusted parties to participate, whereas public chains are kind of even more decentralized. So it's your choice if you know which security model you want to have. So in terms of private blockchain providers in general, like there's Chain, there's a few others, like there's Digital Asset Holdings, there's Clearmatics, there's a few others. They all tend to, you know, a lot of them either sort of build their own platforms, or some of them they actually even fork the Ethereum engine and they sort of swap the consensus algorithm for something else. So there's you know, there's lots of different ones that kind of make different trade-offs.
Yeah, since I don't understand that you need to charge the gas to run the program, so to be able to run the program online for a long time enough, but to be able to recharge the gas.
So an important point here is that so first of all, programs, they can run multiple times, right? So a program runs every time you send a transaction to it. So within the scope of one particular transaction, there is a limit to how long the program can run, and that limit basically is the block gas limit. So a single transaction cannot cause more than 3 million steps worth of execution. So if you want to get around that, you basically have to find some way to kind of split what you're trying to do into multiple transactions.
Yeah. May I ask for more, further away from the real-time communication program on that? The transaction speed allow you for that kind of case, what about when the chat message, how long I can wait for the confirmation?
Right, okay, so in Ethereum particularly, the time between blocks is on average about 17 seconds. So, you know, that is much closer to real time than Bitcoin, but it's definitely not close enough to real time for some applications. If you want to do something that's even faster, then you could try to experiment with the state channel approach, because in the normal case, that approach gives you basically the speed of, you know, basically the same speed as running on a central server, but if the central server breaks, then, you know, it might take, you know, a couple of blocks in before it sort of switches to a different one, but even still during that period of time, even though things will be very slow, it'll still be completely secure. Yeah.
Considering your background in Bitcoin and the ecosystem, how do you feel about banks appropriating technology you're currently developing?
I mean, banks are definitely free to use the technology as they see fit. I mean, I think it's, as long as we can make sure that the underlying platforms remain open and that it remains possible for, you know, people to freely innovate on top of them, then, you know, anyone innovating on top of them is fine.
No. Okay, great. So thank you once more, Vitalik, and I would like to give you a small token of appreciation, something which cannot be used to sign smart contracts, but something that can be used to sign real contracts. Okay, so thank you very much. Okay, great. So it was really a great pleasure to have you all.